Well, good morning, everyone, or maybe good evening. I don't know where is your time zone. So, first of all, welcome everyone. I'm really excited to share this discussion with you this morning. Um, First of all, let me introduce our guest here. Our major discussion for today is that's a way that you can discuss maybe one of the most crises that you have in science here, how we actually can advance in science, and of course, a way I can actually try to advance in science, especially how can you increase reproducibility, especially with the techniques about statistics and of course different methods as well. In the sense, I'd like to invite you to join us first here, Professor Vivek. Professor Vivek is a member of the marketing faculty at the Kelly School of Business in Indiana University, and assistant professor. Prior to academic career, he works in the IT industry for 12 years, and he kindly stay with us in this. Very welcome to the Federal University of the US, Professor Vivek.
Thank you, Ricardo, and welcome everyone. Ricardo, am I audible clearly?
Yes, that's good enough. Thank you very much.
Thank you. So the title of this conversation is there a reproducibility crisis in science? I'll first break down the words and then I'll offer my opinions. So reproducibility here refers to an entity's ability to recreate the findings that have been reported in scientific research. And within scientific research, we are focusing on the research that gets published in scientific academic journals. So we are looking at academics or professors or academic staff conducting research, identifying those findings, publishing them in academic journals, and then the consumers of this research using or reading those academic journal articles to replicate or reproduce those findings. Now, what does reproducibility crisis means? The word crisis is strong here, and the underlying idea is that when these consumers of academic research articles are unable to reproduce or replicate the findings that the authors produced, that leads to a crisis. That leads to a crisis of trust or the lack thereof, distrust, mistrust, and believability in those academic research findings. And when the consumers don't believe, they cannot put those findings to use. So the underlying tenet of academic research is to solve a social or a business problem and then provide solutions or alternatives that the users of research, which could be governments, regulators, consumers, or businesses, can deploy and improve their outcomes. Now, I'll try to answer this question. Is there a reproducibility crisis in science? Short answer, no. It's not a crisis, but over the last few years, there has been an increasing incidents and instances of journals, academic journals, redacting academic articles. And the most common reason for a journal to withdraw an academic article is that they suspect the findings. And this practice has existed in natural sciences as well as business sciences. So you pick up any academic journal and you may find some instances that in the last few years, this practice of journals withdrawing academic articles has become a bit common, which is a red flag. But it is also an opportunity, and I'll give you instances of how this problem has become an opportunity. I'm a business professor, so I'll focus now on the business journals. As I've experienced in the last 2-3 years, more and more academic journals are now requiring the submitting authors, that is, the professors or authors who write academic papers, to submit their code and their data at the time of acceptance of the article. And for those of you who don't know how an academic article traverses a journey, what typically happens is the and a team of academic authors will write an article and then they will submit it to the journal. The journal identifies some editors and reviewers who review um, the manuscript, suggest some changes, and then the manuscript goes through multiple rounds of review and eventually might get accepted. So, what these journals have done, some journals, is that if and when the journal accepts the article, at that point they require the authors to submit their software code and the data. Now, the data could have been generated through simulation or experimental studies using employees or consumers as participants, or it could have been obtained through a survey of managers, regulatory agencies, politicians, or it could have been observational or archival or secondary data, which basically means, for example, if I want to study whether advertising by a company increases its sales. So what I do is I go to a database, I buy data, or there might be a freely available public database. I obtain the data on multiple companies' advertising spending and sales over multiple years, and then I estimate using a structural model, using a regression model, some form of econometrics or statistics. I model the relationship between advertising spending and sales. So at the time of acceptance of my article, the journal will say, Vivek, you need to submit your data, whichever way you collected the data, and the software code that you wrote to analyze the data. The assumption now is that any user of my or reader of my academic article can use my data and run my code on that data and should be able to replicate the same tables and figures that are reported in the paper. You see, that is reproducibility. Now, there's an instrumental perspective to this, that people can reproduce what you've done, but then there's a higher order value to this reproducibility. Just by sharing your data and code, you've signaled to the users that it's all in the open. They now have the control. They can run the code on the data and reproduce the tables and understand what the author did. Why is this important? This is important because this is science. This is not consulting. That is the difference between an academic research and the research that a McKinsey, a Price Waterhouse Coopers, a Deloitte does. There is low transparency. Or do you pick up any newspapers? For example, US News and World Reports claim that they survey or they do research of students, their parents, and academic institutions, and they rate academic institutions or universities on various programs. Say, undergraduate program in psychology, you may see that Stanford rates number one, something, something, but they don't share the data with you. Even if you read the methodology document, you will not get 100% clarity on how exactly the data were collected. This is where academic research is different from the reporting that journalists do and the consulting that these management consulting firms do. And that trust between research and the users of research is fundamental difference between what universities produce and what media houses and consulting firms produce. Okay, so that is a change that has happened in I would say the last 3 to 5 years. But let's be critical. What is this change? This change is that at the time of acceptance, authors are required to submit the data and the code. However, what some journals are doing, and I'll particularly mention the Journal of Marketing, and they started this practice from effective January 1st of 2023. The Journal of Marketing, which is a flagship journal in the marketing field, they require that at every round of review, the authors must provide a link where they have provided the data and the code. Now that is a stronger level of transparency and disclosure, because in the earlier disclosure policy that I told you, the journals were asking the authors to submit the code and data at the time of acceptance. But the odds of acceptance or the probability of a manuscript being accepted at elite journals in business is about 7 to 8%. Now, what Journal of Marketing is saying is that, oh, forget the acceptance. That may or may not happen and may happen 3 years or 5 years down the line. Every time you submit a manuscript, right? When it is a new manuscript, when it is a revised manuscript, you must give us the code and the data, which also means that the journal will now have a repository, and maybe at some point later in time, they will share all these data and codes. You will see how the data and the code have changed over the course of a manuscript. A manuscript typically goes through, say, 3 to 5 rounds of review. At every round, you will know how the authors changed the data. Why did they change the data? What were the edits to the code made? Why were those edits made? Are these edits and the additional data helping or hurting the readability of the manuscript and the value of the manuscript or the relevance of the manuscript? Now, but from what I know, this is the only Journal of Marketing, that has introduced this change. Now, thus far, I have made the case that asking authors to disclose their data and code is good for science. It helps reproducibility. But then there is always the opposite side of whatever argument one makes. So, why is it costly? It is costly, and whom is it costly for? It is costly for the authors. So, I routinely submit manuscripts to journals in management, operations, marketing, finance, accounting. Submitting code. So there are two problems over here, or two costs that authors incur. The first is submission. The entire transaction cost of preparing a clean code and preparing a clean data set that someone can understand and submitting it to the journal requires effort. And it's the effort is not only in terms of time, but it's also in terms of being able to structure your code and the data. Those of you who have ever written code would know how difficult it could be to read someone else's computer code. It can be very, very difficult for the simple reasons. For example, each one of us have idiosyncratic ways of naming variables. For example, most of us, despite years and decades of software writing training, do not put appropriate comments in our code. So preparing code that someone else can use and interpret is always hard. So that's the first problem. That's an effort or a cost that authors have to incur. The second problem is that of, can I share this code? So go back to what I said a few minutes ago. If my data have been purchased by a data provider company, or if I have obtained the data in partnership with a real company, or maybe I have interviewed people, I have collected survey data. Who owns the data? Do I have the intellectual property, or does the intellectual property reside with someone else? These are gray areas, and these are areas on which the journal does not provide you clarity, because that's outside the journal's purview. So the decision making is that of the researcher, and often the researcher might not know, because these rules have not been well defined. Now, whose job is it to define these rules? That's a separate conversation. But when I submit my data, I basically look at the contract that I signed with the company, with the data provider that gave me, for example, 1,500 companies, advertising, spending, and sales. Now, I don't own those data. I just bought a subscription to the data. If I start sharing these data to the journals, and the journals start making these data publicly downloadable from their website, that data provider company will run out of business, and they will likely to sue me. So knowing what data I can submit to the journal, what I cannot submit, that's a gray area, and on which authors don't really have clarity. Authors can submit their code, because code is their intellectual property. But if the code in itself has been written by a lot of effort, and if the code is a contribution in the manuscript, the authors will hesitate to share that code, because I would have written that code after 6 months, and now someone else will be able to use that code, and maybe because the code becomes free, because it's science, it's academic research, it becomes free for everyone. Someone can take that code and maybe develop a software program or an app and file it for patent. So there is a lack of clarity on what is it that I'm allowed to share, what should I hide. And there is, from what I understand, there is not yet a dialogue between the authors and the journals or the editors, or where they can ask questions. But the beauty of all this is that these changes are happening. But as more and more journals introduce these policies of data disclosure, and as more and more authors start sharing the data, they would become well versed, and there would be, over a period of time, a community where people would be comfortable asking questions and others will answer those questions. And overall, the field of academic research or science will improve. And what I currently see as an opportunity for reproducibility, that opportunity will manifest. The potential that I see will actually come to fruition. So eventually, what will happen, I'm hoping, is that academics will do research and they will produce everything that they have created, not just the paper, the manuscript, but also the code and the data that they have used, if the paper is empirical. And the users of this research will have greater access to knowledge. And depending upon their comfort level and their level of interest, some people will only read the article, others will use the code and the data to reproduce those findings. But eventually, as a collective, as the producers of research or knowledge, and as the consumers or users of that knowledge, the entire ecosystem will become vibrant and we will be able to help each other in much better ways. Uh, Thank you very much, Ricardo, for asking me those questions. I'll pass the baton back to Ricardo. And dear listeners, if you ever have questions, claps or slaps or critiques, please pass it back to me, because at the end, we are what we ask. Thank you. Back to you, Ricardo.
Sure. Thank you very much, Professor Vivek. Let me make some highlights to make some analogy here. So first of all, thank you, Professor Denilson Teixeira, that here with us. Here's the mentor of this program, FG Doutoral. Thank you very much for allowing us to bring this discussion. Thank you very much. And if anyone has some question, no problem to make in Portuguese. I can translate Professor Vivek. Okay. Professor, you said very interesting thing, especially how is important to increase our ability to acting as a programmer to make our research. Because, for example, when you said for us about how important it is to make a code and share with the editors, for example, it's very interesting because usually in the academia and of course in multiple fields that we have, unfortunately, we do not use some like a language as R, Python, something like this. So in your experience, how do you think the students, because here our audience are about master and the PhD candidates, what is your tips for the students that they can improve the skills to develop researches within this perspective that you mentioned for us?
Thank you for asking, Ricardo. So let me paraphrase my understanding of the question. Ricardo is asking that for master students who want to do research and create new knowledge or create new tools, how can they use the reproducibility or the data and code sharing that journals are receiving from the authors? Did I understand the question correctly, Ricardo?
That's correct.
Thank you. So let's assume I'm a master student and I'm interested in data science, artificial intelligence, machine learning. And I'm using this name because this is the most commonly, this is the trend right now. So if I'm interested in, say, generative artificial intelligence or so on. So the first thing I should do is identify academic journals that are elite and that publish the cutting edge research on whatever topic I'm interested in. Second, I should check their data disclosure policy. That is, do these academic journals require the authors of published articles to submit to the journal the code and the data? If they do, then you should go to your university library and you should be able to download the code and the data in addition to the article or the manuscript. Now, what you should do is read the article and then keep looking at the data and the code and establish the correlation. Or basically, you establish the interrelation between what is written in English and the computer code and the math, the data. Then the data could be numeric as well as non numeric. That practice will basically allow you to put yourself in the author's shoes and understand how the research was conducted. And just take a step back. So, what is research? And I'm talking about empirical research over here. I collect some data, I write some code to analyze this data based on some theory or intuition that I have. For example, I have data on advertising and sales, say 15,000 US public companies and 20 years of data. Now, my theory, and this is simple intuition, is the more the advertising spending, the higher the sales. Okay. Now, the author makes some assumptions on how this relationship between advertising spending and sales will be modeled. This relationship will be written in English in the manuscript, and it will be written in the mathematical form or in the computer code form in the software file. Now read that. Just reading the code, the data file, and the article will help you get a complete understanding of how the research was conceptualized. Okay, so you will know, or you will learn not only by reading but also by running the code. Now you should understand what type of advancements or enhancements you need to make or you want to make in the code. For example, you pick up any journal, say machine learning is a journal, and that has produced a new paper on generative artificial intelligence. So it's a superior version of Chat GPT. Let's assume that. Now that article should come with the data that were used to train the generative artificial intelligence tool, generative AI, as well as the computer code that was used to train a new prompt by the user on these data and generate the answer. Read that code. Now understand, now critique that code. Figure out what are the assumptions that the author has made which you do not agree with. And it's just that you don't agree. It's not that you're being too critical about the paper. And it's okay. We are in science, so we should be critical. So read the assumptions that the code is making, and then you figure out a better way of how those assumptions could be relaxed, or what are the costs or inconsistencies in making those assumptions, and you then improve that code. So the beauty is now you have access to the data and the code, which is absolutely cutting edge, and you will, and this knowledge is not available in textbooks or Google as well. Okay, so you are learning the most recent research that has been done by reading the English article, that is the academic article, which is basically text, also the computer code and the numeric and textual or voice or video data. And now you improve that solution. And then if you want, you can if you have a better way, then you can communicate with the authors, because the people who wrote that article and the code are public knowledge. So you can engage with them and suggest ways to improve that. Okay. Ricardo, over back to you, buddy.
Well, thank you very much for your explanation. Feel free, everyone, to make some question. Well, Professor Vivek, like you told me before, we have some appointment now, so I don't want to stuck you with us. So thank you very much for staying with us. I really hope that this is the first one that you are here with in the Federal University of Goiás. Please feel completely free to come back, and of course, try to stay with us all the time. Thank you very much, Professor Vivek.
Thank you very much, Ricardo. Thank you, everyone, for listening. And I welcome you to email me should you have any questions or criticisms as well, please. Thank you.
Okay, thank you very much. Bye-bye. Well, I'd like to invite Professor Vinicius Bray to join us here in our conference. So thank you very much, everyone that stay here with us. Again, feel completely free, everyone, to make some questions for us, okay? I'm very happy with this opportunity to discuss this subject. And of course, it's very important to mention for all of you guys, Bray for me is my mentor. I have the pleasure to make some research with him, because as a researcher, something that Bray really helped me to increase my eyes is to don't understand about the article, but what is the social implication about the study. And when discussed about reproducibility, is very important how actually you can contribute with the science. In this sense, Bray is a reference here in Brazil, especially in marketing field, but he has international connections that he will share with us. So, Bray, thank you very much to join us here in Federal University of Goiás. Thank you very much.
Thank you, Limoges, for the kind introduction and for the invitation to participate on this nice event that you guys prepared. Can you hear me well just before I get started?
That's okay. That's okay for us.
Okay, yeah. For the audience, please feel free to write anything on the comments and make questions. I'll be happy to address your concerns and try to answer your questions. So let me share my screen. Let's see if you can see it. Okay. Can you please let me know if you can see my PowerPoint presentation?
Yes, we can see your PowerPoint here, but it's not
okay, good.
Yes.
Okay, can you see it in presentation mode?
Yes, that's good.
Okay, just double checking because I have two screens here. Sometimes things get messy here. So so my brief talk will be about a paper that I'm writing together with one of my PhD students, Jayani. And this paper is called Would Marketing Science Be Stronger Had It Been Less Frequentist and More Bayesian? We are going to present this working paper on the Global Marketing Conference in South Korea in Seoul next July. And basically, this paper is about this idea of reproducibility crisis. I will respectfully disagree with Professor Vivek because I do believe that there is a crisis, a reproducibility crisis. And this is not my opinion. This is everywhere in the news. It has been everywhere since early 2010s. So we see different perspectives about reproducibility crisis on the mass media, on the press, but also on academic papers. So just as a warm-up information, so this paper published on Nature, the journal, the important journal, it's a survey with 1,500 scientists around the world. And basically, this author, Monia Baker, she asked how much published work in your field is reproducible. As we can see here on the right, we do not have business and social science. We have mostly human science, biology, physics. But it's important to notice that this hard science, most of it seems to be more reproducible, at least based on the opinion of their scientists. But if we consider that we should be here, probably on the other, I would say that half of it is reproducible, which is, of course, a big concern when we think about making making things last, because we need to have knowledge that lasts in science, or at least it's testable and reproducible. Science needs reproducibility. Being more specific about fields closer to our field, so for example, psychology, that is very close, especially to consumer research and marketing. So the thing seems to be a little bit worse. So for example, this paper, this is a very important paper because it has done by a group called Open Science Collaboration. And they published this paper on Science, the journal, the famous journal Science. And there was a worldwide effort to try to replicate famous studies in psychology. And on these two graphs here, you can see two important informations. On the left side here, we see the replications of the most famous psychological effects that we had on the literature, of the psychological literature. And we see the original p-values, they are really, really small, which means that they rejected the null hypothesis and they accepted the alternative hypothesis of the effects that the authors were trying to prove. So we can see that for the published articles, the p-values were really low, which is of course something that we expected. However, when we see the reproducible, the replications, it changed completely. We can see that the p-values are very high, which means that most of the effects were, the null hypothesis were not rejected, and therefore we could not accept the alternative hypothesis and the effect sizes. Thinking about the effect size, which is of course the most important thing, which means that practical significance of what is being studied, on the left side we see almost all positive effect size and quite large in a standardized scale that goes up to 1. And on the replication studies, we see some of the effect size close to 0 and even negative, which is the opposite direction from the original published articles. So this is very serious because it means that most of the most important effect size discovered in the history of psychology were not at all reproducible, which is terrible for science in general. So something, even make jokes of creating a journal of irreproducible results. So this is a kind of joke. But science was in a very dangerous position after so many problems with reproducibility. So this paper that we developed is about the failure to replicate many published findings and research bias that we find. Which are the most important bias that we know? First, there are only significant papers usually get published. So what are significant effects are those below the p-value level of 0.05, which is something that I will comment about next. Also the selection bias, that only significant results get published. And also the report biases, that only significant results reported in paper, because some of the non-significant effects, usually they are not reported. And finally, and most importantly, the overall idea of misuse of frequentist statistics. So these, all these problems together, they bring an important issue about the science lack of credibility because of this publication bias, selection bias, and reporting bias. So thinking about marketing science, the key question here for us is how much the poor or inadequate use of frequentist statistics is responsible for the replication crisis. We don't have a study in marketing that tested all the most important marketing science effect sizes, but based on the experience that we found on psychology, on medicine, and in many other fields, we suppose that things could be or should be, or at least they may be quite similar in marketing. So this paper thinks and discusses this problem and thinks about what can be done to solve this issue. So the basic contributions that we are looking for in this paper is to evaluate the quality of the frequentist statistics application in marketing. And more specifically, we are worried about quantitative evaluation of the most cited published papers in the history of the field. We created an overall index of reproducibility. We are calling it replication index, RI in short. And also we address if we find problems with frequentist statistics, whether we can use Bayesian statistics, which is the most important. We have two important areas of statistics today. So frequentist is the most used, and Bayesian statistics is a kind of competitor. And we are addressing on this paper whether Bayesian statistics could overcome some of the limitations that we found on frequentist papers. So it's a more technical paper that we discuss statistical aspects, and I believe it's can be helpful for the audience to complement Professor's Vivek talk earlier. So very briefly, so frequent statistics takes care about discussions of p-value and significant level, which we know by type 1 error. Also, it has confidence intervals are something important for its core knowledge. And there is a lot of problems with power, statistical power, misinterpretations when we use no hypothesis significant statistical test, no hypothesis statistical test. The power usually is considered as the type 2 error. So we have type 1 error, which is significance level, and we have type 2 error, which is the statistical power. Basically, frequentist statistics refers to the dominant branch of statistics. So the core notion of this branch is that any experiment can be considered one in an infinite sequence of possible repetitions. And this is in bold, this text in bold explains why the label frequentist, because it's people suppose that that specific experiment is one of the multiple possible repetitions. But of course, it rarely happens because usually the research draws conclusions from the one experiment only. He or she doesn't do a sequence of possible repetitions. So the idea of assuming that a large number of experimental repetitions happen or would happen, this hypothetical notion rarely exists because people do not replicate their own experiments many times to see if the results stand out or keep stable in the long run. And this is the notion of frequentism that comes from this idea of replication and frequency over a period of time with repeated sampling. This idea came out of two big minds, Ronald Fisher and Carl Pearson, on the early 20th century. But the p-value problems, the idea of p-value problems came out of these two brilliant minds, especially because their original ideas were not respected. Why? Because the definition of significance level, which is alpha, is the idea of falsely rejecting the null hypothesis, H0. And the confusion that happened after the initial discovery of Fisher and Pearson is the confusion that the null hypothesis that was initially developed by Fisher papers was confused with the type 2 error, which relates to statistical power that was originally a Pearson's original idea. So both ideas from Fisher and Pearson were mixed, but they were different because one was, the first one, Fisher was thinking about the probability of falsely rejecting H0, while Pearson was worried about statistical power, which is a different idea. So p-values and statistical significance, they measure different concepts, and we treat them as if they were measuring the same concept. And importantly, frequentist statistics does not allow any kind of statement about parameters, confidence level, and this is one of the very common mistakes that we see in science and in journals. Also, another important issue that we commonly find on the literature is that a low p-value, usually we consider a low p-value below 0.05, and this is something that came out of the blue. This number really doesn't mean anything. It was a kind of convention, a rule of thumb that people start to use, and then it became a kind of gold standard. But we see a lot of criticism on the literature about it. So a low p-value does not represent any chance of the alternative hypothesis being true. So what we can say about testing the null hypothesis H0, and when it's below 0.05, this is the probability of rejecting the null hypothesis. We cannot say that the alternative hypothesis is going to be true, which is usually a very common mistake. So a low p-value is not necessarily an evidence of a strong effect size. And we are very concerned usually about effect size, which is what we are trying to test in our research. So we often confuse statistical significance, which is a measure of the p-value, with practical importance, which should be measured by effect size. So when we have a low p-value and we have a statistical significance, we usually consider that we have a practical importance because of effect size, but they have nothing to do one with the other. So the idea of null hypothesis significant test is that this 0.05 threshold usually makes people think that dichotomically in terms of significant and non-significance, which is usually not important because what is really important is the effect size. This is something that should be the priority of our research. And finally, the p-value misinterpretation, it reverberates into other types of wrong interpretations, especially regarding confidence interval and power. We usually consider that confidence interval are a good measurement of precision and which is not. And we think that it's less, when we think about the confidence interval, we think that our result, the average effect size, it's more in the middle of the confidence interval, where it can be anywhere in the confidence interval, which is usually something that people don't take into consideration. So going briefly to this paper, I'm gonna show here what we have done. So we developed this problem about taking the 100 most important papers cited, the most cited papers in the history of 4 journals: Journal of Marketing, Journal of Marketing Research, Marketing Science, and Journal of Consumer Research. And we collected the 800 most cited. We filtered the empirical papers, the 100 most cited empirical papers. So we excluded all the theoretical papers. So we kept only the 100 most cited papers in each of these journals. So at the end, we had 400 empirical papers. And we extracted the data using an algorithm that we developed to collect some information about the papers. So very briefly, the reproducibility index that we are trying to propose on this paper, it takes into account 10 different perspectives. First, we analyze if each paper discusses measurement theory and error or any sampling issues, because this is important for statistical power and other issues. We asked if the paper makes any assumptions about the model, like linearity, non-linearity, etc. We also analyzed if the paper reported the exact p-value and not just an inequality like p less than 0.05, because the p-value is an exact number and it should be reported not as an inequality, but its exact value. And we also addressed if the p-value was interpreted correctly on those papers. The four element of evaluation was if the paper discussed the effect size, relevance, and magnitude, and not only if the hypothesis was accepted or not. We also analyzed if the paper compared and analyzed different effect size magnitudes and into different studies, especially on the consumer behavior literature, where we usually have many different experiments in one paper. The sixth element was if the paper reported and analyzed correctly the confidence interval and its implications for the effect. The seventh, if the effect size confidence interval was relatively small, because if the confidence interval is really big, it means that the effect is not, the author is not very sure about where the effect size is and what is its magnitude. We analyze if the paper show reports or discuss any issue about power, which is the type 2 error. Also, we analyzed if there was any discussion about file drawer, which means was there any kind of unsuccessful study problem or any p-hacking. P-hacking is when the author tortures the data, let's say, trying to exclude outliers and make different types of manipulations of the data, trying to find a low p-value. And the last issue that we analyzed, if there was any kind of concern about open science procedures, like the ones that Professor Vivek mentioned before me, like putting, for example, sharing the data, sharing the code, sharing in a public repository like Open Science Foundation, and so on. So going to the results of this paper, what I would like to call your attention is that from the 800 initial papers that we collected, the most cited in the history, we can see here that the frequentist on this third column here, we can see the number of frequentist statistics paper. So 72% are frequentists, 7% are Bayesian papers using another tradition, statistical tradition, and just 80% use another type of statistical tradition beyond frequentist and Bayesian. 12% of the papers were theoretical. As you can see, there is some bias in terms of frequentist on the Journal of Marketing Research and JCR. And on marketing science, we find less frequentist statistics and more Bayesian statistics. So the most important result of this paper so far is this reproducibility index, where we compare in box plots the average reproducibility index from 0 to 10 of the most important journals in marketing. So the Journal of Marketing, Journal of Marketing Research, the JCR, and Marketing Science. As you can see here, so the 0.5 would be the average reproducibility index. Ideally, we would expect all the papers to be at 10, but we see that just one paper the JCR has is fully reproducible, and most of the papers are below the number 5 in a 0 to 10 scale. And the overall reproducibility index of marketing, the marketing field, considering this sample of the 400 most cited papers, 100 from each most cited empirical papers, 100 from each of the journal, is 4.20. And the JCR is the least reproducible. We can see here that JCR has some papers that are not reproducible at all in terms of these different indexes. The most typical problems, measurement theory. So considering the average grade that each of those, the 10 elements of reproducibility that we studied, we calculated an average of each of them from 0 to 10. So in terms of the number 1 was quite reasonably good, 0.76 from 0 to 1. The model assumptions was also reasonably good, but the p-value reporting was very low, just 0.18 from 0 to 10. So this was the p-value reporting. There are a lot of problems with the most cited papers in marketing history. The effect size magnitude was reasonably good, almost 1, and the effect size comparison was also reasonably good. When we think about the other, confidence interval reporting was very poor, 0.17 from 0 to 10. The confidence interval width rarely reported. Statistical power rarely discussed. File drawer and p-hacking issues almost a complete absence of discussion. And open science replication very rarely addressed as well. So in short, there are a lot of recommendations that we can take out of this research. First, procedural solutions. People need to report many different types of statistics and trying to share data that would allow for replication and reproducibility. In terms of design and data collection, we also report on the paper the ways that people could improve their research design and make the data collection more reproducible. Thinking about the statistical analysis, there are some comments that we make on the paper about how to improve trying to avoid many data torture and trying to make things more clear in terms of data analysis. The null hypothesis significance test is a core issue, and especially about correctly use the p-value, inform the exact p-value and not an inequality. Also to report effect size and to discuss the effect size magnitude. It's important to report confidence intervals and discuss their length. They should be small and not big. And also discussions about the statistical power are really, really important, because this is a very important notion of failing when someone accepts alternative hypothesis when it's false. So it's very crucial issue in the statistics. And finally, we discuss on the paper an alternative approach, that is the use of Bayesian statistics. And this is, of course, a very complex subject that I don't want to be arrogant and trying to explain Bayesian inference in a couple of minutes. But basically, on the paper, we try to compare some advantages of Bayesian statistics compared to frequentist statistics. And very briefly, what Bayesian statistics does is to calculate a posterior distribution. So instead of trying to calculate one specific number of one effect size, for example, that we want to address in our paper, we try to address some prior knowledge that we have about a phenomenon. And then we see the likelihood, which is the data we collect based on that phenomenon. And multiplying one by the other, we have a posterior distribution that measures our uncertainty about any phenomena of interest that we have in our hands. So graphically, what happens on Bayesian statistics is that based on some prior belief, some prior knowledge that we have about the phenomena of interest, we collect data, which is the evidence, and then we have a more precise view, which is the posterior. So these are three basic notions about Bayesian inference that we try to address. And why is it important? On this table, we try to compare both approaches, frequentist and Bayesian approach, and we try to address why Bayesian approach is could be an important alternative that could solve most of the problems that we identified on this paper. So in terms of testing an hypothesis using a p-value which has a lot of problems, as I have mentioned previously, we can use a Bayes factor that measures the strength of the alternative hypothesis compared to the null hypothesis. Is a much more fair comparison instead of just rejecting the null hypothesis and supposing that the alternative hypothesis is true. Also, in terms of effect size, the frequentist approach has a point estimate, and the Bayesian approach doesn't give us just one point estimate, which is something really problematic when we think about science, because it's very unlikely that things in life have just one average. So on the Bayesian approach, we have a posterior distribution, a probability distribution of possibilities of that effect size. So we have an uncertainty measurement. If that distribution is very spread out, so we have a low level of certainty. If it's very narrow, we have a very good level of certainty. So this is more fair and more clear in terms of thinking about effect size. Also about effect size interval, usually on frequentist approach is an unknown parameter because we don't know exactly where it is. And when we have a probability distribution on the Bayesian approach, we know the probability and how narrow this probability is. And finally, thinking about power analysis, in terms of width of the confidence interval, it's not very clear when we think about frequentist approach, because if it's very wide, it can be anywhere on the confidence interval. And on the Bayesian approach, we can think about this probability distribution about the specific values that we have as important values. So to finish my talk, some conclusions for this research is that overall, the marketing science reproducibility index is low, and it should be much higher. We would expect something much higher, and there is a lot of concern about this average of 4.2 in a 0 to 10 scale. Also, there is a lot of misuse of null hypothesis significance testing and p-value use in marketing, and there is a lot of also effect size discussion and analysis, and also lack of power analysis. One possibility to solve most of these problems is the Bayesian approach that we bring on the paper, but of course there are other issues that could be addressed easily if authors take more precautions in terms of using appropriately frequentist statistics theory. Okay, so this is my talk. Thank you very much again, Ricardo Limoges, for the invitation. Let me stop my screen presentation here. Sorry about that. I'm confusing my two screens. Okay, I think I'm back. Thank you. Thank you again for the invitation. I hope this video and audio was clear enough, because the paper is not very easy to understand because it makes two different statistical traditions. Thank you, Ricardo Limongi.
Sure. Thank you very much, Bray. Given a highlight, so again, thank you, Professor Denilson, for the invitation for all of us in the Projeto UFG Doutoral. I can see that our Dean of Postgraduate, Professor Felipe, stay with us. Thank you very much for everyone here. And Bray, let me allow you here and discuss about some questions that you received during your presentation. For example, the first one is from Rafael. He's a student of our business administration post program here. His question is about how much of the reproducibility problem is related to the methodologies or related to the nature of the research objects themselves. So in the sense, Bray, do you think the problem is the methodology or the conductor of the researcher?
Well, it can be both. It can be both. Let me try to explain. So in terms of the nature of the research objects or objectives, you need to have a very clear effect size that you want to test. If your research problem is not well defined, if you have more than one effect that you are trying to test, you're going to have problems about testing different types of effects, and then you're going to have more than one effect size. So it's very important to start any research with a very clear effect that you want to test. If you have, and I would recommend just one, not more than one research, not more than one effect size. So this is my answer to the second part of the question. To the first part of the question, how much of the reproducibility problem is related to the methodology? It's 100% related to the methodology, because frequentist statistics, if adequately addressed, it might have a very low level of problems. But if you do a good sampling, if you do the appropriate statistical tests, if you do a good data preparation, if you share your code, if you analyze the p-value correctly, if you do all your homework properly, then you should not have so many problems. The problems is they exist because of the misuse of the frequentist statistics. And most of us, we misuse. We do things wrongly, we interpret wrongly, we don't discuss power issues, we don't take power issues into consideration when we calculate sample size. So the problem is that frequentist statistics, it has many different aspects that should be considered when you create your research design. And most people don't do all these steps that they should do, and then they run the analysis and interpret incorrectly. So the problem is in all the process of using frequentist statistics, as we have found on this research.
Thank you. Khalil asked us about how we could recognize the impacts of such crises. In the sense, Bray, I don't know if you agree, but as a researcher, sometimes if you don't understand the method section, actually we can replicate. In the sense, we have a problem, because how can I understand the improvement of the article? Actually, can I apply in our research? Do you think this is the one point that is the impact of such crisis, the difficulty to replicating our studies, for example?
Yeah, the impacts are, so it's very, I was discussing yesterday with my students, comparing social science and business and marketing more specifically with other fields like physics. There is a big difference between our field and these other fields. So for example, if one researcher runs an experiment in physics, usually he or she will have a lab with most of the environment is controlled. So when you kind of crash two particles, everything is controlled, everything is kind of measured. You try to isolate other covariables that could interfere on the phenomena. When we think about social science, it's a totally different world. We have many possible covariates that might interfere on the relationship between our independent variable and our dependent variable. So whenever we try, whenever we don't control these relationships with some types of observations or measurements, we are always in danger of having different or alternative explanations to our effect size. So that's why it's so important to use different methods to address the same phenomenon. And this is something that we are seeing more and more in marketing. The top journals nowadays, they require different types of methods. So, for example, most of the phenomena that we are seeing published on the Journal of Marketing nowadays, and some of the papers on JCR, we see not with just lab experiments, but also with field experiments, with observational experiments, with secondary data analysis, and so on. So it's very important to have different types of data, different types of research methods in place, because you can see the phenomena throughout different lenses. And this is important because if the phenomena exists, if the effect size exists, it should be stable. It doesn't matter the type of method and the type of data that you are using. So this is why it's so important to have a training in method when we think about PhD students and master students, because this is what will allow you to run different types of research using different types of methods to see how consistent your effect size are.
Great. Let me try to summarize the wonderful question, Professor Wilson, because he said, most of human social sciences database are books, documents, and other theoretical predictions, not always from journals. Actually, we really thought that from journals we have the big database, the correct database. In this sense, but in times of artificial intelligence advancement, how can we prevent more reproducibility?
Well, so I think there are two issues here on Professor Wilson's question. First, that the knowledge are based on books and other theoretical production. Yeah. So when we think about theoretical development, it's very hard to isolate. When we think about social science, it's very hard to isolate theory from empirical research, because most of the theory usually should be useful for reality, right? If you don't have a good, so my view is that a good theory should be useful to describe, to explain, and to predict reality. If your theory does not describe, explains, or predicts something, then I don't see its usefulness. In that sense, a theory should be connected with empirical data, with the real world. And I would say even that a theory must be connected with the real world. Otherwise, it's not useful. So in that sense, if you write a theoretical book trying to predict things or to describe things that do not happen in reality, I don't see that this is a good book, and it should not be used. The second part of the question, the AI advancement, how could we prevent more reproducibility? I'm not sure if I understood the question. So I think you are addressing the concerns about maybe, let me see if we do not develop tools to avoid it, we are really in a deep crisis following the ethical crisis. I believe that you are concerned about ChatGPT stuff and these language models that we nowadays use in an everyday basis. Well, I'm not that concerned about the use of these type of tools, because what they don't do everything, they don't do the job, and they are very helpful for some parts of the research. So for example, I use it all the time to correct bugs in my code, and also to help me with some issues of trying to address problems with my text. But I'm not concerned that this will change reproducibility, because at the end, the researcher needs to take the decision about how to interpret p-value, how to misuse it, if he or she will use correctly or not the statistical theory. So the language model will not do the job for you, at least the way it's developed right now. And I've seen a lot of wrong suggestions about the AI model. So this is something important that students should be very aware about, not trusting blindly the ChatGPT and other tools, because when they make a lot of wrong suggestions. So you need to have some skills and some knowledge to know whether the proposal of the ChatGPT is correct or not. So you should not trust it blindly at all. This is something very important.
Thank you very much. Well, just to remember something that we already discussed until here. First, Professor Vivek showed us how it is important to submit and how to develop an article with a script and code and the database. And now Professor Bray discussed very deeply with us the different approach that you have in statistics that can actually improve our research. In the sense, the next talk, it's about open science and how this open science is a philosophy. Actually, how can we implement the open science issues in our research? In the sense, I will share with you a video from Professor Subani from Pakistan. Unfortunately, he can't stay with us because he has some issues with his flight. So I will share with this video that he make a bigger presentation about open science. And of course, in the end of this video, I come back with Professor Bray to discuss all your questions. And of course, the final quotes here in our audience. Okay, thank you very much. Please, can you share the video?
Dr. Subhani here, Dean of Business School at Alva University, and the ambassador of DHA, first F, and the lead of Creative Commons Pakistan, and also director of Forge Level. Well, I'll be talking on open science and open access or open accessibility, and further the reproducibility crisis. Obviously, open science is a movement that seeks to make scientific research more transparent, accessible, and collaborative. It is an approach to scientific research that emphasizes open data, open source software, and open access to research publications. This is the map to describe open science and its various elements. Open science has several elements, which include open accessibility, open data, open reproducible research, open scientific evaluation, open science policies, open science tools. And open accessibility has further many other elements. Open accessibility normally, describes the open access model of publications. And open access models of publications are categorized into three categories: the gold open access model, green open access model, and diamond open access. I'll be in the later slide discussing these three models one by one. And in the open access or open accessibility, we also further discuss the further elements, open access definitions and initiatives. And open access initiatives, basically, there are many other kinds of open access initiatives. And they are DHA, Creative Commons, etc. The other big element of open science is open data. Open data has many further elements which can be open big data, open data definitions, open data journals, open data standards, open data use and reuse. There's a difference between open data use and reuse and open access use and reuse. Open access, reuse, and reuse, it comes in open accessibility, the very major element of open science. And open data use and reuse, obviously, it is the component of open data. So then the open gum data. So the other element of open science, as mentioned in this map, is open reproducible research, which has further several categories to discuss, which may include definition of open reproducible research, irreproducible studies, open lab and notebooks, open science workflows, open science and open source and open science, reproducibility guidelines, reproducibility testing. Another important element which is normally ignored by many people, it is basically open science definition. Then the open science evaluation. The open science evaluation has further two components. One is open metrics and impact, and second is open peer review. Open metrics and impact has further several elements in it. Those are altmetric, bibliometrics, scientometric, and bibliometrics. These are the several tools, matrices to address the impact of the discovery. So then, obviously, open peer review is like one of the peer reviews discovery for. It is also known as transcript review. And there are many other titles for open peer review, like Oxford, etc. Then open science guidelines. Obviously, it is also one of the important elements of open science pattern. Then open science policies, which has further two elements, organizational metadata and subject policies. Subject policies can be discussed into two categories: open access policy, open data policies. And organizational mandate are basically as per the authors. It includes funders policies, government policies, institution policies, etc. And open science tools also is one of the important element of open science. It includes the open repositories such as REPAC, SSR, and many others, open services and open workflows tools. So this is the map which defines the several elements of open science. And I would say, obviously, like several elements of open accessibility, so just one of the components of open science itself. Obviously, these all elements mentioned in this map can further be basically comprehended in the discussion in the slides. I'll share this slide to Dr. Ricardo, and people who are interested to further learn on this map, they can actually go through these slides. So, anyways, basically, when we are basically addressing open accessibility in open science, obviously this map contains the resources for disciplines across all open science principles, including articles, commentaries, blog posts, highlighting established and original open science practices, participants, and research fields. open access sources, including THA, Lensmark. These are the resources where you can actually search journals, open access journals by discipline. And further, basically, there are many other platforms like SSRM, like Square, where you can basically search preprints, because these platforms are basically famous for being preprint repositories. Obviously, like open accessibility of is part of when we are actually addressing this. So we cannot forget to discuss open data. Open data is also one of the important elements of open science. There are many repositories in fact addressing open data, archiving open data itself by focusing on care principles. Open hardware, open source software is also in fact one of the components of open science. Open evaluations and openness assessment. These are basically, obviously, the key elements of open science for evaluating the starting point and giving the chance to everyone to read assessment outcomes herself. Alunos basically they were doing fantastically amazing activities for addressing the open evaluations, open peer review. And there are many other platforms they are basically in fact focusing on. They are basically addressing and advocating open access, open peer review, such as they were credit themselves. There, I would say for the better sharing, we should now shift our peer review process towards open peer review process of the transmitted, because it is the most transmitted process for this company. Then the citizen science projects, the platforms as provided by NASA, also in fact the key component of open science. Then the identifiers given by many folks like Crossref and others also in fact are helpful tool, in my opinion, to promote open access in general. The goal of open science is to make research more efficient and effective, to increase the quality and impact of research, and to make science technology more accessible to the commons. Open access large international movement that seeks to grant free and open access, open online access to information such as publication of data. The benefits of open access. Scientific work is, I believe, a lot, because if you're actually publishing your research work while using open access model of publications, so you're basically giving more exposure to your work than the practitioners can apply your findings. You may have a chance for higher citation rate. The researcher can be influenced through your work, and further, the policymaker can be influenced through your work. Hence, you can dictate influenced policymakers. Public can access your findings. The researchers in developing countries consider this, and there are many other benefits. A publication is defined open access when there is no financial, legal, technical barriers to accessing. That is to say, when anyone can read, download, copy, distribute, try to search within the information or use it or in education or in any other way within the legal frameworks. If a publication is basically combining these all attributes, and that publication is called open access publications. Open access publication covers all types of peer-reviewed publications, both journals, articles, and books. Initially, the open access movement focused mainly on journal articles, and it was basically the major business model of publishers. That was, and because of this model, there was an exponential rise in access journals, and then, obviously, because of it, the noise also arrived, which is so to speak as the. Anyways, when we are actually talking on open access journals, so we cannot forget the contribution of DOJ. DOJ, basically, one of the biggest open access database addressing open access journals, no matter in what model they are actually being published, whether the model publication is green, gold, or dominant open access models. If they are actually being published while actually deploying any of these three open access models, they can be deployed with DOJ database. DOJ addresses 80 languages, or covered 80 languages, 132 countries are represented in DOJ database. Approximately 13,000 journals having no ABC links done open access journals. They are the part of DOJ, and collectively 19,000 journals are basically. Those are basically following either of the any of the open access model. They are the open access database, which is DOJ, and DOJ records approximately 84 lakh articles in its database. As mentioned before, slightly, open access is really in three ways: theoretical, bring and diametrical. Open access is where other covers cost of publishing business, also has to be published. Undergo open access model, the articles are published in DOJ's journals or articles are having licenses as a good science. The model of open access one whereby the content of a published article can be made available in a format only after a period of involvement. 24 months, depending on which study publishers are defined by different science. Diamond open access model is also one of the models, one of the bright models of open access publications. There's no money either to publish or to pay for it. But obviously, since there is no money involved in this model, so publishing cannot make revenue and business with this model. That's why this model is not so popular. Then, like DOJ basically addresses open access journals similarly. Yeah, like DOJ, Directory of Open Access Books, also a platform that addresses open access books, approximately 12,000 books of the chapters from the 20 publishers are Directory of Open Access Books. Open access publication platforms, there are several platforms like PAG, SSRM, Square, OpenAir, and many others. You can basically, those are the preprint servers or the repositories for the open access publication can be accessed. Not only the open access publications and the open access articles and open access books are important to be discussed when addressing accessibility in open science. But we should also discuss the open accessibility of open thesis. There are many platforms for this, like NARCIS, like DART. They're basically working and advocating accessibility of open thesis. Now, coming on open data. Open data, open science contains open access to academic publications, and also open data, research data, learning tools, software, and when addressing research data, we mean open data. In open science, when addressing research data, open science, which means we're addressing open data. Open data offers many benefits to scholarship, raises visibility of research results. It is citable thanks to concept UI, and it encourages the reuse of your data for new research question and purposes. In 2016, Dutch Research Council developed a policy in the area of data management. They wanted research data should have the fair principles that should be findable, accessible, interoperable, and reusable. So any data that is open access data or the open data, it should have fair principles. It should comply with fair principle as developed by Dutch Research Council. There are many repositories working for archiving the open data itself, like DANS, like etc. They are basically providing the durable storage and accessibility of research database. By the way, DANS provides to like 41,000 data sets. Those are openly accessible for the researchers. And we should not forget, when discussing the open access journals, open access publications, open books, open access books, open data or so, we should not forget open access publishers. There are many publishers advocate open science and accessibility of content. Springer, Severe Value, Taylor Francis, many others, they're basically advocating the open accessibility of scholarly content side by side. The subscriptions and open access publishers can also be dipped out from the database of DHA. Now, coming on, what is reproducibility? Reproducibility is a science, means that results of a scientific study can be independently replicable by other researchers using the same methods. It is considered as cornerstone of science because it allows for verification of and helps to establish the reliability of scientific results. Coming on what comes in reproducibility science. So, in my opinion, there are three components that comes in reproducibility. Those are transparency of methods and accessibility and statistical significance. Transparency of methods means the scientific data about the methods researchers are using should be provided to every leader, departments, to every stakeholders, and for their applications. The next element is accessibility. Researchers must make that available to other researchers that you can very well define this. And then the statistical significance of the are very important. Okay, when you're addressing the size. Results must be, it means results must be significant. Because it must be significant for example. It should be statistically significant. Means the probability of the findings acting by chance should be applied. Now, coming on, what comes in reproducibility crisis in science? So there are 3 components. Those can be discussed in the crisis. The reproducibility crisis in science, which are large association design and adequate analyses and selective reporting of results. Reproducibility crisis has raised concern about the reliability of scientific research and has led to efforts to improve scientific practice and promote reproducibility. Now, what matters the most to define reproducibility crisis? I believe the inability of scientists to replicate or produce, to reproduce findings from previous studies. I believe this thing matters the most. Because it is indicating that initial results may not be accurate or reliable. This can lead to a lack of confidence in scientific research and scientific methods. And obviously, this can lead to a lack of confidence in scientific research. Then further, serious implication for the advancement of knowledge and development of effective treatments of intelligence. Thank you very much for listening to me today on open science, open accessibility, and reproducibility. If you have any question, please vouch your questions via email to Dr. Reproducibility. I'll be more than happy to answer those questions. Thank you very much.
Okay, thank you for sharing this video. Just to make some notes, guys, just about to discuss how actually we can apply the open science initiative. For example, if you try to develop your research, consider to use repository as GitHub or OSF, for example. That's a way that you can actually try to improve some techniques like Professor Subani shared with us. And to finish our big day here, again, thank you very much for the postgraduate dean for sharing this invitation for all of us and the Professor Denilson to invite us. Just to finish, Bri, if you can, I have just one more request, if I can make this. With your experience as a researcher and as a professor in a postgraduate program for a long time, and as a researcher with connections around the world, if you can give for our audience some tips for our students to develop more relevant researches and some skills that they can develop during this master and during this PhD. If you can share us some tips with your experience.
Sure, Limoges. Can you hear me well?
Yes, that's okay.
But well, there are some practical issues that someone that wants to make her research more reproducible can adopt. So for example, I would start creating a public repository where you can share all your research materials. So a very good open source is the OSF, Open Science Foundation. Let me share it here on the event notes. Let me see here. So I will share here on the comments. Let's see if I can type here. I don't believe it's open to me. Fortunately,
if you want to put in our private chat, I can send
yeah.
for the
Okay,
here.
I will do it. Yeah, sure. So this is the address, the Open Science Foundation. So you can open a public repo, anonymous, and you can share all your data and code for reviewers and for general audience. If you are a coder, if you work with data science, usually you will want to have your code available in a public repository as GitHub if you work with more data science. So I'm also pasting the address. And in general, what I would recommend is that you try to combine the data analysis with a textual explanation. So I use all the time Google Colab. Let me also share the code here on the notes. Google Colab, which I think it's a very useful research for collaborating with co-authors and sharing your text combined with your code. And if you use these 3 different tools plus one data science language, open source language like Python, which is the one that I use mostly, and I highly recommend it. So I think this is a good practice. Also, the appropriate use of statistics is very important. So if you are a frequentist statistician, then you should hear carefully what, for example, books like as Hare and colleagues multivariate data analysis show. Also, if you are a Bayesian analyst, I would go for the PyMC library in Python, which is the most advanced project. Let me share the code here as well. I think there are a lot of good suggestions for where to proceed to learn more about Bayesian statistics. I also pasted on the chat notes. So I think this would be probably my broad suggestions. Use an open source language. Try to make your code and your text available in a public repository. Share the codes and the data the most you can. Of course, sometimes you cannot share the data, but at least the code, try to share it in this public repo on the Open Science Foundation or in GitHub. And try to make everything as open as possible. And this would probably help a lot your readers to reproduce your work.
Okay, so Bray, again, thank you very, very much for sharing your time with us, with Federal University of Goiás. Thank you very much for all the audience that stay with us during this almost 2 hours. So thank you very much. Our major goal with this panel is to discuss how actually we are, during students or professor research as well, really need to improve our skills to apply this worry that we discussed during this morning about the reproducibility. And of course, like Bray shared with us, it's very important to consider to use some repositories open as well, as like he said, GitHub, OSF. Try to make some search, guys. Try to understand how the couple of articles that you use in your field, how they develop some strategies in this sense. So again, thank you very much for the invitation, Professor Denilson, PRPG of the our Dean for Postgraduate. Thank you very much, Professor Marina, Stefan, everyone that really helped to make this happen here in the university. So thank you very much, everyone, for staying with us during this period. And see you in the next panel. Thank you very much, guys. Bye-bye.
Bye-bye.